You can start writing. First 10 minutes, write down all the formulae that we have learned from integral of x power n till cosecant x. Okay, write down all the formulae in order. I'll not even give the question. So next exercise is about integration of some trigonometric functions. Okay. So till now we saw how to integrate sin x, cos x and all those things, right? Now we will see how to integrate when you have sin square x, cos square x and other parameters. So for this, there are certain set of formulae that you need to know. So write down the heading as integration of some trigonometric functions. Okay. First is integral of sin x dx is how much? Minus cos x plus c. Whereas integral of sin square x dx, if I ask you what is the value, you cannot find it directly. So for that, what we need to do is we need to use certain trigonometric identities and then solve them. For that, from your last year's concept, if you recollect, cos 2x can be written as cos square x minus sin square x, or you can write it as 2 cos square x minus 1, or 1 minus 2 sin square x. So cos 2x is equal to, if I write it as 1 minus 2 sin square x, then 2 sin square x can be brought to the left and cos 2x can be taken to the right. So when you do this, you get 2 sin square x is equal to 1 minus cos 2x, and sin square x will be equal to 1 minus cos 2x divided by 2. So integral of sin square x can be rewritten as integral of 1 minus cos 2x divided by 2 dx. So this will be integral of dx by 2 minus integral of cos 2x by 2 dx. So integral of dx is x, and you already have a 2 in the denominator, minus half into integral of cos 2x is sin 2x divided by 2 plus c. So the answer will be x by 2 minus sin 2x by 4 plus c. Right. So next is, in a similar context, if you want to do, or if you want to find the integral of cos square x dx, then how do we solve it? So cos square x can be written as 1 plus cos 2x divided by 2. So integral of 1 plus cos 2x divided by 2 dx. So this will become integral of dx by 2 plus half into integral of cos 2x dx. So integral of dx by 2 is half x plus half into integral of cos 2x is sin 2x divided by 2 plus c. So you will have x by 2 plus sin 2x by 4 plus c. Similarly, the other set of formulae that you're supposed to know are, you have sin A plus sin B formula, or I can call it as, you have sin C plus sin D formula, which is given as 2 sin of C plus D by 2 cos of C minus D divided by 2. In a similar way, you have sin C minus sin D, which is going to be 2 cos of C plus D divided by 2 sin of C minus D divided by 2. Similarly, when you have cos C plus cos D, it is going to be 2 cos of C plus D divided by 2 cos of C minus D divided by 2. And you have cos C minus cos D, it will be minus 2 sin of C plus D by 2 sin of C minus D divided by 2. Now see, for example, if I have a question where it is sin 2x cos x dx. So when it is of this form, if you observe, the product of sin and cos is occurring in this identity and this identity, in both these identities. But if you observe, sin of a greater angle, cos of a smaller angle is appearing in the first identity. Means what you need to do is, you need to write the sin 2x into cos x in the format of sin C plus sin D. For that, what you need to do is multiply and divide with 2 so that you get half into integral of 2 sin 2x cos x is actually formed by sine of 2x plus x. That is sine 3x plus sine of 2x minus x, which is x. So what I'm trying to tell you is 2 sin 2x cos x is the same as sin 3x plus sin x. Now you have an integral symbol. It is easy for you to integrate it. Half into integral of sin 3x dx plus half into integral of sin x dx. So answer will be sin 3x divided by 6 plus sin x divided by 2 plus c. Oh, cos, sorry, minus cos. Correction. So half into integral of sin 3x will give us minus cos 3x divided by 3 plus half into integral of sin x will give us minus cos x. So answer will be minus cos 3x by 6 minus cos x divided by 2 plus c. Clear? So in a similar format, I'm giving you, yeah, you want to copy it?
Sir, I didn't get like how 2 sin 2x cos x, you are taking that sin x plus sin y formula.
See, 2 sine of bigger angle, cos of smaller angle. Listen, sine of bigger angle, cos of smaller angle can be written as sin C plus sin D. So if you observe all the four combinations, you either have sine of a bigger angle into cos of smaller angle, or you have cos of bigger angle into sine of smaller angle, or you have cos of an angle into cos of an angle, or you have sine of an angle and sine of an angle. So whenever it is a combination of sine and cos, the first thing that you need to check for is which trigonometric function is having greater value. Suppose sine has greater value, then it can be written as sin C plus sin D. If cos is having a bigger value, then it can be written in terms of sin C minus sin D. If it is cos and cos, then it can be written in the form of cos C plus cos D. If it is combination of sine and sine, it can be written as cos C minus cos D. Is that clear? So having this in mind, I want to give you another problem, integral of, I want you to try this, cos 3x into cos 2x dx. Okay. So multiply and divide with 2 in the first place, the first step, right? Once you do that, what are we supposed to do? Half into integral of, this will become cos 5x plus cos x. Is that what you wrote? Just cos 5x plus cos x. Why cos 5x? Because first cos, you need to add both the angles. Second cos, you need to subtract the angles. Is that point clear to everyone? See, if you understand this logic, the whole exercise is done. Are you clear with this? Shall I proceed? So half into integral of cos 5x dx plus half into integral of cos x dx. So what will be the answer? Sin 5x divided by 10 plus sin x divided by 2 plus c. Is this clear? So this is all about the different kinds of formulae that you need to apply. Okay. With this knowledge, we can get started with the problems. So integral of sine square 2x plus 5. So integral of sine square 2x plus 5 dx. First thing is 2x plus 5, put it as t, which implies 2 dx is equal to dt. From this, what can I conclude? Dx will be equal to dt divided by 2. Right? So integral of sine square 2x plus 5 will be t into, in the place of dx, I can write it as dt divided by 2. So half into integral of sine square t dt. So half into, how can I write sine square t? Going forward, you can do this. You can write it as 1 minus cos 2t divided by 2 dt. So this will be equal to 1 by 4 into integral of dt minus integral of cos 2t dt, which will give you the value as t by 4, which will give you the value as t by 4 minus sine 2t divided by 8 plus c. We know that t is 2x plus 5. So we will get 2x plus 5 divided by 4 minus sine of 4x plus 10 divided by 8 plus c. So this will be the final answer. Did you observe when I was teaching the concept? Observe பண்ணி third step என்னது? So x is replaced with t, so that's why I wrote it as t. Is it clear? Next is integral of sin 3x into cos 4x. Integral of sin 3x into cos 4x dx. So I would better rearrange and write it as integral of cos 4x into sin 3x dx. Because I'll always ensure that the bigger angle is written first and the smaller angle is written second. So multiply and dividing with 2 will give you half into integral of 2 times cos of a bigger angle, sine of a smaller angle is sine 4x plus 3x minus sine 4x minus 3x, which is going to give you x dx. So 1 by 2 into integral of sine 7x is minus cos 7x divided by 2 minus 1 by 2 into integral of sin x is minus cos x plus c. So this will give you minus cos 7x divided by 4 plus cos x divided by 2 plus c. And this will be the final answer. Proceeding to the next one. Shall I? Here, if you observe, this is integral of cos 4x, sorry, cos 6x. I repeat, wait. Here it is integral of cos 6x, cos 4x, and cos 2x dx. So if I take these two terms first, what I can do is I will multiply and divide it with 2. When I do this, I get half into cos into cos is cos c plus cos t. So this can be written as cos of 6x plus 4x, that is 10x, minus cos of 6x minus 4x, that is 2x, and yeah, plus dx. So 1 by 2 into integral of cos 10x into cos 2x plus 1 by 2 into integral of cos 2x into cos 2x dx. So 1 by 2 into, again I'll multiply and divide it with 2. So it will become 1 by 4 into 2 cos A cos B. That is cos of 10x plus 2x, which is going to be 12x, plus cos of 10x minus 2x, which is going to be 8x, plus here also I'll multiply and divide it with 2, so that it becomes 1 by 4 of integral of cos of 2x into 2x, which is going to be cos 2x plus 2x, which is going to be cos 4x, plus cos of 2x minus 2x, which is going to be 0 dx. So here also you have a dx. So 1 by 4 into integral of cos 12x dx is going to be sin 12x divided by 12 plus cos 8x will be cos sin 8x divided by 8 plus 1 by 4 into cos 4x is integral of cos 4x is sin 4x by 4 plus cos 0 is 1 and integral of dx is x plus c. So the final answer would be sin 12x divided by 48 plus sin 8x divided by 32 plus sin 4x divided by 16 plus x by 4 plus c.
Sir,
Tell me.
sir, in the previous question, the final answer, so the last question. So shouldn't it be minus cos 7x by 14?
Why is it cos 7x? Oh, sorry, I made a mistake. Yes. So it is 7 here. Yes. So it is 14. Correct. Where? This one. Dua. This step only, no? This part. Because cos 2x into cos 2x. Here. Should I proceed? So here, if you observe, it is sine cube of something. So for that, we know that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Right? So then what is sine cube theta? That will be 3 sine theta minus sine 3 theta, the whole divided by 4. So integral of sine cube of 2x plus 1 dx will be equal to 1/4 of integral of 3 times sine theta. Here theta is 2x plus 1 minus sine 3 into again the theta value is going to be 2x plus 1. So everything as dx. Right. 3 by 4 into you have integral of sine 2x plus 1 minus 1 by 4 into integral of sine 6x plus 3 dx. So this will be 3 by 4 into integral of sine is minus cos 2x plus 1 divided by 2 minus 1 by 4 into integral of sine 6x plus 3 is minus cos 6x plus 3 divided by 6 plus c. So answer will be minus 3 by 4. So answer will be minus 3 by 8 into cos of 2x plus 1 plus 1 by 24 into cos of 6x plus 3 plus c. Shall I proceed? integral of sine cube x into cos cube x dx. Remember, the idea here is whenever sine and cos have same angle, okay, multiply and divide with 2. Okay. So what I can do here is integral of, can I write this as sin x into cos x the whole cube dx? It's the same as sin cube x into cos cube x. So what I will do is integral of multiply and divide with 2, and it is sin x into cos x the whole cube dx. So the denominator 2 will become what? 2 cube. So it will become 1 by 8 into integral of, what is 2 sin x cos x, which is inside the bracket? It is sin cube 2x dx. Because 2 sin x cos x is sin 2x. Right? So this will be equal to 1 by 8 into integral of sin cube theta can be written as 3 sin theta minus sin 3 theta minus sin 3 theta the whole divided by 4. This dx. So 1 divided by 32, or it is going to be 3 divided by 32 into sin 2x dx is going to be minus cos 2x divided by 2 minus 1 divided by 32 into sin is going to be minus cos 6x divided by 6 plus c. So answer will be minus 3 divided by 64 into cos 2x plus 1 divided by 6 into 32 is 192 cos 6x plus c. This will be the required answer.
So sine cube x formula is
There is no direct formula for sin cube x. For sin cube x, you first need to write sin 3x and then proceed.
okay, fine.
Shall I proceed to the next one? So this problem I want you to try. What is the answer?
Minus sin 6x by 24 plus sin 4x by 16 plus sin 2x by 16.
Minus 4 sin x by
Plus sin 4x plus sin 4x by 16. Plus sin 2x
by
So it should be in terms of cos.
no, I think it will be in terms of sine only, because when it is sine into sine, right? So when it is sine 3x into sine 2x, if you take this part alone, you multiply and divide it with 2. So you will have half into cos 3x plus 2x, which will give you 5x, minus cos x, but with a minus sign. Is it clear? Into what are you left out with inside? Into you're left with this sin x. I think answer should be in terms of what she told is right. It should be in terms of cos. It is in terms of cos, no? Cos is right. Okay. So here multiply and divide with 2. Here also multiply and divide with 2. Minus 1 by 4 into 2 sin x into cos 5x is how much? It is integral of sin 6x minus sin 4x plus 1 by 4 into integral of sin 2x dx. So minus 1 by 4 into sin 6x dx will be minus cos 6x by 4 minus cos 4x divided by 16 minus cos 2x divided by 8 plus c. So answer should be cos 6x by 16 minus cos 4x by 16 minus cos 2x by 8 plus c. This should be, oh, sorry. Here it is 6, so it should be 24. Is it right? So proceed with the next one. multiply and divide with 2. So you'll get half into, this will be minus cos, or I'll take the minus sign outside. Cos of 12x minus cos 4x dx, integral of this. So minus cos 12x by 2 dx minus integral of cos 4x by 2 dx minus sin 12x by 24 minus sin 4x by 8 plus c. Only once. You're integrating only once. Double again. No need. I split the term and wrote it as 2. That's it.
Cos C minus cos C is minus 2 C.
Whereas I push the minus this side. That is the reason why I put a minus sign. Which one? Oh, minus is already there. Yes, plus. One minute. Okay. Okay. So I think we can stop with this. So remaining problems will complete it next class. Okay. So I hope it is clear. No? I will wind up.